shoulder hurts. Okay, let's go check the code. Let's go check the code. Let's go check the code. Where is the code? Dead kernel. The kernel has died and the automatic restart has failed. It is possible the kernel cannot be restarted. If you are not able to restart the kernel, you will be silly. Be able to save the notebook, but running code will no longer work until the notebook is reopened. I couldn't understand the last sentence. If you are not able to restart the kernel, okay, you will still be able to save the notebook, but running code will no longer work until the notebook is reopened. Okay, try restart. So let's look at the code and see if we find anything problematic. So we define an upper bound works, and then we have nf. Okay, let's try other values for ns, mean theta, mean omega, all of this stuff when it chance, we can play with them. Cubic, so we have the cubic that gives sigma a theta I, and y sigma a omega. So let me just write this down. Fuck it, doesn't matter. Ellipse takes x and y r, right, and sees if you are inside the ellipse or outside the ellipse. Sounds good to me. And then x y y, we checked it before, by the way, and L for lambda. So upper bound is m is 1, and then we see if the length of the interval is less than epsilon, and we check if a is outside the ellipse, b is inside the ellipse, and we go choose an interval, and k greater than 0. So okay, this part, if k is less than 0, the equation for ellipse, right? A plus b over 2, c is the midpoint of the interval, x and y are cubic of c and r, okay, get distracted. Yeah, don't look at your phone, guys. K, so k checks if x and y, we get it for the ellipse, right? How? Sees the lambda, solves it, gives us the x, y is completely based on lambda. So k computes if x and y, and with the given r, we are inside or outside. For the c, k less than 0 means we are inside the ellipse, so we should choose c and a, right? K equals 0 means we are on the ellipse. C is the lambda, that's the shed. Wait, what happens when we break? We go for the next r, exactly. If k is greater than 0, a, c, k is greater than 0, we are outside. We need to take c and b. Exactly. And repeat here xx. Yeah, we got the value of x and y we want, and we also get the value of lambda. Sounds good. Print m is not big enough. Okay, these are to check that lambda, we are inside and outside, and that's the curve we get. But why is it like this when we get close to -1? Let's check what happens when we get close. What value of sigma AI theta we expect, by the way. That's a good point. Thanks for bringing that up, Mr. Nuripur. That's a good point. What is happening to x where r is -1? Do you have me? Yep. So okay. When r is -1, like it doesn't seem sigma AI omega has any problem. Sigma AI theta I has problem. That's it. This is the equation for sigma AI theta I, and its lambda is something positive. Oh, we have this division by -1. I see. Do you see that, guys? We have this, if you look at this, we have over 1 plus r here. Let's not have it, right? Let's not have it. Okay, this is not a big issue, we couldn't. So let's do that. Can we get rid of all of this stuff? 2 over r squared, get rid of it. And so this is my cubic equation. This is our cubic equation. Let's multiply it by r squared 1 plus r. 1 plus r squared. We will have 2 lambda n f minus r 1 plus r. By the way, this is not the cubic equation we have, but still let's assume we will have 1 plus r here, x minus 2 lambda n f minus r 1 plus r minus lambda n f minus r times r squared, right? 1 plus r, this one minus r squared equals, we can do it on both codes, equals what? Mu ai squared. By the way, we need to check for mu ai too. Mu ai squared over t squared. Well, t squared sigma theta I squared is not a big problem. X squared. But what is mu ai? Do I have it here? I prefer to have it here. Oh, what about the rest? Over x squared, by the way. Thanks for reminding me. Mu ai squared over t squared. So it should be r squared 1 plus r over x squared. So when r is minus 1, what is it happening here? R is minus 1, specifically. When r is minus 1, our equation turns to minus lambda nf. By the way, can we do this? Can we do this? I don't know. Where is the cubic equation coming from? Cubic equation comes from stability for the second PSD constraint. That's it, right? After, but it comes from stability. I don't know if we can multiply it by 1 plus r and then solve it or not. I don't know how, if the solutions stay like move continuously. Substituting the expression for v in the last equation. Exactly. What is mu ai, by the way? We don't have mu ai. Oh, mu ai is set. For an obedient mechanism, mu ai is set. Let's open another overleaf. Where is it? Okay, is it this? The mu is this. Okay. So S mu omega plus T mu theta I. So okay, that is all good. Mu ai is S mu omega plus T mu theta I, where 1 minus n minus 1 r. This root has 1 over is f, which we are not closing. Okay, that's all good. R is minus 1. We will have this equation. That would be cool. That would be cool if I scrolled here. Oh shit, it is happening. Okay, you can scroll here and it scrolls here. That's actually cool. Okay. Yeah, that is not a big deal for us now. Actually, our mu ai is 0. We do not like that. I do not like that. Because it is removing. We need to play with, okay. We need to play with the parameters of the problem. We are just simulating. Oh my god. Okay, r minus 1. Let's assume what's happening here then. Then we will have 0, 0. So it is minus lambda nf minus r squared equals 0, which is not true. No. R is minus 1, lambda nf plus 1 should be 0, lambda should be minus 1 over nf, which is not true. So it suggests for r minus 1 we should have lambda equals 0. Interesting. What do we have here for what do we have? What do we have here for lambda? Is that I can just look at the monitor and draw everything. Okay. Damn guys, I think I have to go to take a break. So it seems let's first multiply it and see how the situation changes. And we are assuming that here we are assuming lambda is always positive. But what if lambda is 0? Right? For r equals minus 1, we want lambda 0. Let's see how it goes. Lambda 0. Oh, this is the second one. If lambda is 0, it means that the first one is not binding. Alright. And that's where the code is getting interesting. We don't have no ellipse. Or we can say the cubic is inside. That's what we can say actually. Lambda is 0, we are inside. So it turns to two over r squared sigma AI theta I. This equation stays the same shit. I squared minus R1 plus R. It's 2R squared minus R is okay, equals mu AI squared C squared sigma theta I squared X squared. Okay, this is X. Okay. The problem when R is -1, we should start far earlier. No? That's the problem, okay. Wait, when did that happen? R is -1, so let's see here. Whenever this happened, no, these are all okay. When R is -1, we don't have any of these terms. That's where, okay, when R is -1, the situation is different. And R is greater than -1, everything is okay, right? Because this equation is the one that gives us part of the cubic equation here, right? And it comes from this one, second PSD, derivating, but when R is -1, you cannot do that. This is so 1 is compared to sigma I omega. For that, doesn't matter. 1 is with respect to sigma I theta I. Sigma I theta. Okay, the parameters are sigma I theta I, sigma I omega, and sigma I aj. So R equal -1 and R equals F are separate, because you can see that these equations change, right? Because we have this term that disappears, sigma I aj. Also, we have this sigma I theta I and sigma I theta I that disappear. Sigma I omega doesn't matter. So let me write it here for myself. For R equal -1 and R equal F, Lagrangians should need to be updated. We can go over them later. That's not a big issue. Okay. The thing is that lambda cannot be zero. I have problem with that. Lambda cannot be zero because if lambda is zero, it means that we are an interior point of the ellipse. First one is not binding, but we already checked it. So what we do is, yeah, we already checked it. We compute sigma Aj from this one, put it here, and compute it. We have it here. Oh my god. Put it in the first one. It's just sigma ai theta I and sigma ai omega. Now, and if the lambda 0, lambda positive means first one is also binding. The situation is deterministic, which is the thing that the code is telling us. However, let's assume lambda is 0. Let's solve that. Okay, let's skip this part. Let's say when lambda is 0. Am I doing the right thing though? So we will. Where is nu coming from? AI omega gives us this. Exactly. So sigma AI theta I gives us the last one. And okay. Best code ever. In the best code ever, we have checked if, oh, okay, for except r minus 1 we have checked. We checked if it is an interior point, right? For a equals 0, we cubic a of r, and we check that ellipse is greater than 0. We check that we are outside the ellipse. Otherwise, we would get a print, it's an interior point. And dude. Seems for R negative it is always binding. I don't know. Mm-hmm. Let's also play with other variables. Mm-hmm. So S is 1, T is 1, mean, I want to set it 1. Where, I don't give a fuck. Yeah, I don't think there is any point in changing T sigma theta I squared and S sigma omega squared. But let's see this. Okay, it takes some time. Takes some time, guys. Be patient. MIT Kickboxing Club. I know they have hard days now. First, they are missing me, and some other stuff happening, but I don't know what's happening exactly. Did it change? Let's say XX. X was the problem of this. Same shit. That's the problem when, okay, we had this problem when R is minus 1. Okay, it's not a problem to be honest. L, let's see, oh, okay, so it changed, but it's still positive. Maybe it is the case. Let's do it for R minus 1 now. Okay, let's change the code first. Let's change the code first to the version that I am multiplying everything by 1 plus R squared. This comes for cubic. 1 plus R. Oh, I can do it here, huh? Yeah. Motherfucker, every time I touch the insert. R squared times 1 plus R times this. What? What's wrong with this? Which line? Why? We cannot? That's so stupid. Doesn't make sense. So, what is 2 times 1 and 2? Oh, shoot. Okay. How should I do that? I don't know. Help me, guys. Okay. How can I scale Python like 2 times 1 Oh, okay. Should put it after. That doesn't make sense, to be honest. No, it's the same shit. Tile. No, I don't want that. What is wrong? If you want to directly multiply each element of the array by a scalar, you should use element-wise multiplication rather than replicating then concatenating. Here is how you can do it. Original array, scaling factor, scaled array. You just an asterisk sign. I don't know what. R. Let me see. What is that? R times 1 and 2. What not? R times array, motherfucker, 1 and 2. Copy. That's better. Should go. Okay, now let's see what's up. Maybe that's the shit. Okay. Seems like that. I don't know what is wrong with it though. Maybe it is the solution. Even if we set them as 0, Oh, it puts an asterisk sign when it's being done. Okay, got it. Meanwhile, let's go over. Yeah, it's the same thing. Oh, okay. Why did I assume that lambda is 0? Because for r equals -1. Oh, okay. I just multiplied this equation here by r squared 1 plus r, while this will not be the r anymore. For r equal -1, we should go from the beginning, because that differentiation in the third stability doesn't work the same way anymore. So this is our inequality. These are right. There is no problem with them. Well, I had mean A. What is mean A? Mean A, okay. Maybe obedience also affects, probably affects, but for R positive. Overleaf. That's it. Obedience. Okay, truthfulness, obedience. That's it. So obedience doesn't matter at all for R negative. Okay, obedience says mu AI is, but for the sigmas it is all good. CS mu omega. It doesn't depend on R plus T mu theta I. 1 minus n minus 1 r sigma ai squared equals n minus 1 r sigma ai aj plus s sigma ai omega plus t sigma ai theta I, and sigma ai theta I equals n minus 1 r sigma ai theta j plus t sigma theta I squared. Okay, so let's go for, oh my god. Oh, fuck. Fuck. For r equals, by the way, r is never -1. Okay, our intervals are open. So we don't, okay. Let me show you what I'm gonna change here. Get a red marker, make it a bit bigger. U, because R is always greater than -1 and less than F. Never happens. So we don't need. Maybe computationally, what? No. We don't need that. All right. That's good, but we don't need. So this is the solution. Okay, what is wrong with lambda r being positive? It seems lambda is always negative. Well, that's actually good too. it seems no, it's not true, because previously we had this constraint. When is it true that lambda is always, can we say that lambda is always positive? We can say lambda is always positive if, well, the graphs we have are suggesting that beforehand we had this ratio, this one. That would say if this happens, delta will be 0. But now it seems, okay, this is something based on R. So if I change this T sigma theta I squared and make it big enough, so I want to make S sigma omega squared big enough. So it is positive right now based on R, right? I want to make S sigma omega big enough so it changed the sign of the, not the sign, but the inequality changes its direction. Therefore, so we can do that. We can do that by making sigma. Maybe we get lambda 0. Let's do it, try it. Sigma omega, but if I make it 10,000. Do it now. So it still has the star, which means we should wait. Asterisk. Okay, it's done. Okay. See? Now we get lambdas which we have interior point. Actually, for our code is doing well, by the way. But none of them we are still m equal 1 is a big number. Lambda never gets to, oh, for all of them. Okay, interesting. It's on good upper bound. Let's get it like that. Let's do it again. Okay, good. Maybe it is the form. Who knows? Yeah. So now we have to solve for the case lambda is 0, because it happens, and then we will go for lambda positive. Okay, even for 10 didn't happen, but let's see. Look at it. Let's see how it looks. Looks the same shit. Okay. Interesting. Lambda 0, and we should add some independent noise to make it maximally anti-correlated. Let's do it. So what happens when lambda is 0? This is our inequality. So stabilities stay the same. Ellipse, well, ellipse stay the same. That's the point. So these equations stay the same. So we know ellipse is positive. Is that it? No. Oh, lambda is 0. Okay. Okay, his lambda and my lambda are a bit different. I think we checked it before, it's not a big problem, yep. So because lambda and nu are non-negative, same thing. It's just about KKT, right? What are you doing, dude? Okay, okay, lambda equals 0. Lambda is 0. Let me see if I can write it like that. I can see that. Then, first PSD. Oh, yeah, I can, but it sucks. First PSD. Yeah, I don't like that. Will be plus some delta, I would say delta positive. And then this delta and the other delta should make the relationship. I don't know why, how though. So we have this equation, we have these three equations, we have these, but now lambda is 0. And we know that 1 over r squared, I have it or no? Yeah, it should be cleaned up. Okay, that's it. I have it here. So now this first one, will be an inequality, strict one. So we should change it to delta plus delta equals this. So delta is the difference. Now how is that related to that inequality that I showed you earlier? Okay, let's see what are the changes. Nu first, lambda is 0. Nu will be minus or 1 plus r, which is oh, okay, now you can see why we should study r positive and negative differently. We are still r negative though. R is still negative. Oh, you cannot see, or you can see, okay. Nu will be minus r over 1 plus r. Sigma AI omega will be, this will be very terrifying. Sigma AI omega will be S sigma omega squared over 2n times minus 1 over r. Could you see that? So everything now changes when r changes sign. What else? You want sigma AIAJ now. Sigma AIAJ. Okay. Sigma AIAJ's value comes from these new inequalities. So interesting. I think we won't have huge changes, but we still got some changes. What happens to sigma AI theta j and sigma AI omega squared? Nothing. They are still the same stuff based on sigma AI theta I and sigma AI omega. So sigma AI j, we need to get rid of it. We have done similar computation before, so I will go find it. That's where we got the ellipse. Here. So now, let me copy all of this shit. So, yeah, we also added plus epsilon here. You can see that we added with this plus epsilon here because of the lambda 0. It should be minus epsilon. Now it's just plus delta. So we need to clean up some stuff. Second one is still a quality. First one changes. Okay. So here we will have plus delta equals this. And let me move it to the top because we are used to call it the first one. Okay, now let's also, so it should be times f minus r. This is f minus r. The other one is r plus. So we will have again some equations similar to the ellipse with a difference though. So we have 1 plus r over r squared. 1 plus r. Keep your core tight, guys. 1 plus r squared sigma theta I squared I speak loud. F minus R sigma AI theta I minus ft sigma theta I squared plus 1 plus R delta plus F minus R over R squared sigma theta I squared there's 1 plus R sigma AI theta I minus T sigma theta I squared plus N over sigma omega squared. Yeah, dude. Sigma AI omega squared equals okay, 1 plus R and F minus R will be 1 plus F S sigma AI omega T sigma theta I plus 1 plus F T sigma AI theta I, and here those two cancel out. All right, so this sign is also less than or equal. Let's keep it in mind. So the ellipse equation changes to I don't know why last time we multiplied the ellipse equation. Oh, this is the ellipse, it's not the cubic. We multiplied cubic by R squared, 1 plus R. So it's just ellipse minus ellipse, right? So we have this term, extra term here, 1 plus R delta, which is positive. That's all it is. Oh my god, what happened to my bag? Oh, I need to bring the ball. Okay, now how everything changes. We have sigma I omega. We have we have sigma I omega. We have lambda. We have nu. Sigma AIAJ can be computed based on sigma AI theta I. Not a problem at all. But sigma, okay, what is sigma? Okay, got it. Sigma AI omega tick, right? AI omega tick, nu tick, lambda tick, sigma AI theta I is the question. Previously sigma AI theta, okay, now it's interesting. Previously sigma AI theta I, we had the curve, right? Cubic. Oh, okay. Oh. Alright, I get it. Previously, okay, sigma AI theta still is a function of lambda based on cubic, right? Everything fine. Oh, lambda is 0, fuck, okay. Oh, okay, good. Lambda is 0, so cubic also gives us sigma AI theta I. Yeah. Sigma AI theta I is a function of lambda. Lambda is 0. And so we have sigma AI theta I too. Yes, we have cubic. Cubic doesn't depend on the first PSD. Alright, we have sigma I theta I from lambda 0. What is the equation of cubic when lambda is 0? Now, just remains to compute delta. What is delta? And that's not difficult. Should be positive. Just let's compute sigma I theta I first. This is the cubic equation. Oh, we have it? No, we don't have it. So that was bullshit. That was previous bullshit that we assumed R is. No, actually it is true. It is lambda 0. Okay. So minus R, 1 plus R, 2 over R squared, X, minus 2 over R squared, lambda, NF, 0 minus R, minus R over 1 plus R mu AI squared, T squared, sigma theta I squared, over X squared. So that's the equation we are. Okay, this gives us the sigma I theta I. Can I solve it? No, I cannot solve it. But the same way we will get it, and then actually this time it is easier. So we have every variable already. Yeah, okay. Oof, dude, my back hurts. Can I look at my phone? Let's see how much time. Let's not look at my phone. Let's not look at my phone. Just last, but I will play Counter-Strike. I will play Counter at the end because I didn't look at my phone. So the code is pretty similar. Whenever we get R, we will say we are interior point and okay, A0. So cubic of A and R, instead we should say A0. Okay, oh, we can do that. Let's just check it. Lambda is 0. It's all good. L is 0. Yep, we are all good. We should in the transition so it's worse than it. We can see that it is worse. So it's all good. We can put lambda 0 in its coefficients, and the coefficient will be doing the same shit. So it is actually what we want. And I don't need to change my code. Okay. So we are coming here where we don't need to change my code every time. We are in this for loop, right? Here, A0, cubic A and R, if ellipse is greater than 0, if ellipse is less than 0, means we are inside interior point, we come to this else, comes interior point, and we can sing, we don't need to change my code! Okay, that's so good. That's what a programmer wants. That's a pro programmer. You know, he codes and suddenly it turns out that the code works for an extension of the problem too. Still, I like to have, let's have these. It's a beautiful thing to have these. And so now we will say L U is NP that append. Well, all of these stay the same. By the way, all of these stay the same. Therefore, Control Sing. I don't need to change my code. We do it. So yeah, like y when we do the, but we didn't compute it though. So if a is 0, x and y, yeah, we compute that already. So we compute them. Ellipse is positive outside, otherwise it's inside. So exactly. Let me make it. Doesn't matter, to be honest. So we are inside. We are interior point. Just want to check cubic with a 0. Oh, cubic first takes lambda, then r. Alright. Cubic is working for us, even for y. It would 0, 0 minus r. Well, shit, it's working. So we have this. Now it's the time for lambda. And we can compute ellipse too. Actually, I will tell you right now, guys, what's happening here. Ellipse, where are you, ellipse? So I can compute plus r delta easily. 1 plus r over r squared where f minus r plus r. I'm dying. F minus r squared sigma plus n f minus 1 plus f s sigma a I minus 1 f t the boom. Okay, the ellipse we compute here turns out to be delta ellipse. If you have me here, I can show you. Wait, what were you watching the whole time? Fuck, okay. Sorry guys, I don't know what happened. Then I changed it, I don't know. So, damn guys, okay, doesn't matter. I was doing the whole thing for myself from the beginning. Okay, the ellipse okay, the equation we have tells us this equation here. That's kind of sad, to be honest. I know because you pay attention to the equations. Here it says ellipse. So we are saying ellipse plus 1 plus r delta equals 0, right? Now, is there anything on ellipse about delta? No, it's not. Where is it? 1 plus r delta plus ellipse is 0. So our ellipse, by the way, our ellipse is positive now. Our ellipse is negative, sorry. Because we are inside, our ellipse is negative. So delta will be ellipse minus ellipse over 1 plus r. So simple. Okay, this is good. How does this delta now relate to our other delta? Dude, I was sharing the whole thing with you. Oh my god, fuck it, happens. Let me check if I am sharing it right now. I wanna cry. Uh, I wanna cry and I wanna lie. No, something else. So how is it? Where is this delta coming from? From um, maximal anti-correlation. We have everything now. We have we have sigma AIAJ. Oh, actually, that is what is. Yeah, that's what it is. No, we have sigma AI theta I. We have sigma AI omega. So we have sigma AIAJ. We have sigma AIAJ from the second one. So delta comes from this added noise we have here. Here, we add some noise to the action recommendation to make it maximally anti-correlated. Because remember, on the, here is our ellipse. We don't have it. Here we have the ellipse, right? For example, here is the center. We are here, right? We have a space. We can add this noise here to go up to this motherfucker boundary or border. And that's what it is. Alright, I need some time to get it in my system. Oh my god, dude. Oh, no. Ah, fuck, dude. So, okay, why do we need added noise? Because it improves our objective. But it comes from the structure of our sigma matrix. Let me see. Oh, let's not lose it on this page. What the fuck is happening here? We had a lemma in the appendix was talking about. Okay. Oh, in both cases. This is a very nice structural result. Which constraint is slack? The slack. Okay, we have this formula. So this is for maximal correlation, we add the same noise. Anti-correlation, we add independent IID normal noises. Where is this formula is coming from? Will be my question, right? So T will use the variable XC or whatever the fuck this is. I can say what it is. This is the most hated Greek letter. XC. C. Alright. I like a big delta better. Well, 20 is the case when we are having it. How do we know? This is the situation. I want to know where it's coming from. Okay. Yeah. Bullshit. I didn't like Oppenheimer. I think Nolan is done. He is, honestly. Go make Batman 4 instead of these bullshit movies you're making. Actually, the last Batman, it was amazing. I liked it a lot. So sigma AI theta I. So Jn is Jn. What is Jn? Where is Jn? So it is A and B. Okay. Equal to B. Fuck. Jn is the matrix all one. Okay. We have its inverse form. So we can compute this stuff, all good. What I want to know is not this one. What I want to know is that we have everything now. We have sigma, all of them. We have mu, all of it. So AI, remember. So once we have sigma, we have everything. We have the A, theta, and omega vector as a Gaussian of mu and k, right? And we know that. Oh, okay. So A is always. Oh, okay. So we can always say A is A minus expected of A equal something like that. Something expected of A given theta and omega minus A plus A. What? No. Okay. It is this plus A minus this shit. Expectation. Okay. Now we want to say this is maximally anti-correlated and gives us delta in the form of epsilon I minus epsilon j. This is not a big thing. This is easy kind of. Because we have to. Where is this coming from? That maximally anti-correlated. From the lemmas, it comes from the lemmas. Okay, we are going to, so we should go read the lemmas. Lemmas and find the delta and delta relation. We have it already, but I have to understand it. Oh, we wanna play the game? Yeah, let's play, guys. I need a fresh. Yeah, okay, we got it. This is the point. We will go study it, no big point, and then we are good. Our code doesn't need to change much, I guess. Yeah, we computed everything about code. Okay, I will run it later. Now it's the time for some guys. Oh, fuck, my shoulder hurts. I don't know how to play, but it may affect me. My life is like already 60%. Yeah. Doesn't go away. Casual. Was it casual? Wait. Do I have you or not? Guys, I don't wanna. For this part, you should not just watch me. Okay, quit. Let's see what's happening here. Okay, you have me. What the fuck? Today, like this session was full of results. I don't know why. Anyways. Let's play the counter, guys. Okay, good. I think tomorrow morning I'm done with that code. I'm sweating, it's so hard here. Let's go one round DDoS and then I want to try a new environment. Dude, here hurts a lot, I don't know. Do you think this weekend I can catch Andy? This guy had a E3. Oh, fuck you! Did I bite or not? Motherfucker. Be nice. And don't kill me, motherfucker! Where are you? Where are you? Don't, these motherfuckers are all here. Guys, don't leave me, guys. They're here. Fuck, what does he have? Kill you with the AWP. Let's go. This is the kind of... Oh, shoot. Don't kill my buddy. Oh, it was Varma. Why do you kill each other casually? Fuck no, okay, let's go. Where are you dogs? You should go ahead. Let's go guys! Oh shoot, dogs. These dogs are dangerous. I will have your back here. I'm going to come over. Oh motherfuckers! Ah! Oh fuck, okay. I was about to... They killed all of us. What is this? This is me. Bitch! Oh, you got my... Oh shit, we can't get this. That's smart. I want one of these blue ones. Oh, shit. Okay, I was warming up, guys. They won't. Fuck, you know. Shit, yeah, this one. Let's go. Oh no! What did I do? That was a good one. F1. I like F1. From now on, I'm on my F1 mode. Actually, I am on F1. Yes, motherfucker! Ah! Oh shoot, dude. Situation is not good. Where are these motherfuckers? Oh, we can kill them here. Ha 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 ha. La 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 la. Dude, leave something for me, brother. Oh, they don't show up here though. Where are they? Bitches. Oh, get their guns! Fuck. What am I doing? What is this? I don't know how to get a gun, by the way. I picked up the bomb. We are dead. Guys, cover me. Oh, father. Who are we shooting? Guys, do not. Why are you doing this? Fuck! I at least did it. How do they appear again? I cannot do that. Oh, this is my buddy. Where am I, by the way? Ooh! Wait, what? I'm a good guy. Dude, look at my rating. I want this. Because I was a good boy. I deserve it. Oh shit, dude! I just bought a new gun. Don't do that to me. If you have the ball, just come out. Don't kill me. Oh, okay, he was my enemy. Okay, good job. But my rating, what about? Oh, dude. Okay, what is the time? I can get back in 7 minutes, guys. 7 minutes, like 4, 6 minutes now. Okay, 3 more rounds. 3 more rounds. 3 more rounds. Each, on average, I should last more than 2 minutes, which is quite the time. B3. Why this? Okay, yeah. Guys, where is the guy with the vest? What are these guys talking? Guys, silent.
Huh?
Don't throw anything.
There's one in the middle.
Oh, monster. Oh, he has a good one. He has a good one. Huh? Is it G? No, why this? Take this motherfucker. Take his. Ooh, guys, I am going to fuck this city up. Oof. I don't know what am I doing, but I know it has different effect. I wish we didn't have the reflection in my eye. Can I hold it next time? Bro, tell me I can't hold it next time. Who is my buddy? Are you here? Where are you? Where are you? Oh shoot, right here. I better escape, dog. Okay, I want more. Don't. Okay. This is oof, that. Yes, green, yeah. You come in front of me, I will kill you. Okay, 2 rounds. Now we wanna go. Fuck, he killed me. I wanna go this time sniper. I'm going sniper, dude. I don't know how to be a sniper. Machine gun, what about that? How dare they? Oh, fuck, dude. Well, if I'm a sniper, I better be with somebody. I need somebody. I need somebody. Okay, somebody else. How many are they? We are all dead? They have a better team.
My uncle touched
I was talking about his uncle. This is me. This is me. I don't know who is. No, don't give it to me, mother. Okay, I think today we are going this because I have the bomb. So there is no point. Motherfucker, I'm going. Guys, cover me. How can I talk to them? Where are my bros? Yes. Oh my fuck you, bro. How sound like from 6 directions. Okay, guys, I have to leave. It was nice to fight next to you. Damn, what is this? Okay. My quads. We come back. Delta connection. Delta connection. And completing the code, running it. That's it. Today it was difficult. Friday night, these fucking guys are all playing counter.